All right, guys, we're going to do lesson 3. There are only 2 questions you have to do on page 221, and that's because they take a little while. But the reason I want to point these out is here's your answers to them, and you'll notice they're kind of weird. There's 63 65ths, and those aren't numbers. We've been getting rad 2s and 2 minus rad 3s and that kind of stuff. So where did this come from? Well, here's my example. I'm going to do this one for you, and then you just follow. But we did something just like this in section 5.3, so this is not too unique. Problem number 48, they gave me cosine s equals negative 15/17, and then they say sine of t is 4/5. Angle S is in quadrant 2, angle T is in quadrant 1. Find sine of S plus T. So I'm doing sin cos cosine. So I go sine of S cosine T plus cosine S sine of T. And you'll notice that right away I could fill in the blanks right here. I already know what the cosine of S is. It's negative 15/17. I could multiply that by the sine of t. They already gave me that. Hey, the problem is I don't know what sine of s or cosine of t is. I have to draw reference triangles to get that part of the puzzle. So here we go. We're going to draw ourselves some reference angles here. Come on, tighten up. There you go. And here's my coordinate system. I got angle S in quadrant 2. And they want me to say the cosine of that angle is negative 15/17. Well, I don't know what this guy over here is. I'm going to call him little a because it makes me think of Pythagorean theorem. So I'm going to say a squared plus negative 15 squared equals 17 squared. And let's see, I did this earlier on my calculator because some numbers I just don't have stuck in my head. Negative 15 squared is 225. 17 squared was 289. I'm going to take it away. Take it away now. And let's see, I'd get myself almost out of room here. A squared equals whatever 289 minus 225 is. That's 64. Oh, well, that's convenient. Hey, I could take the square root, and I get plus or minus 8, but I'm on the positive side of the y-axis here. So I'm going to take that a, and I'm going to erase it. I'm going to make it an 8. You are an 8. Well, that's convenient. Now I could find out what the sine of that angle is. I could say, hey, now I know what sine S is. The sine of S would be opposite over hypotenuse. I still don't know what cosine of t is, though. So I'm going to draw a reference angle for that guy. And they told me that angle T is right here. Come on. In quadrant 1. And I say, okay, well, they were kind to me, too. They told me the sine of that angle. They said the sine of angle T is 4/5. So I go opposite over that. And lucky for me, this is a 3, 4, 5 right triangle. This one's a quickie because I know this one. It's memorized. It's burned in my brain. I should have probably known that one, too, but this is 3 in the afternoon, and I've been recording math lessons all day, so I didn't think that sharp. Anyway, let's find out what the cosine of that is. The cosine of angle T would be 3/5. So I go up here and I go, hey, you are now 3/5. Let's do some work here. On the bottom, it appears that I have common denominators. And 17 times 5 in the bottom is 85. That's what I have in the bottom. In the top, 8 times 3, that's 24. What am I going to do? I'm going to add it to a negative number. I should have just made it a minus, but in the bottom, once again, I have 85, 17 times 5. 15 times 4, that's my buddy 60. So if I want to know the final answer for sine s plus t quantity, I do 24 take away 60. I get negative 36/85. That is the sine of s plus t. See, that was kind of time consuming just to get that part. And then they want me to do this part. Part B, you'll see it in the book, says find the tangent of s plus t. I go, oh man, that means I'm going to do tangent s plus tangent t over 1 minus tangent s tangent t. But that's what it looks like. So let's fill in the blanks. I have already got my reference angles. I have enough room to see them too. So I could say to myself, hey, what is the tangent of S? So I go up to my triangle up here and I go, the tangent of S, and I'm going to write it down below here, is opposite over adjacent plus the tangent of T would be opposite over adjacent. That's the top of my fraction. On the bottom, I have 1 minus. Now, tangent S is once again going to be my negative, so I'm just going to take that thing and make it a positive. Times the tangent of T. And I've got a really ugly double fraction. Couple different ways I could play this game right now. One of them is I could combine the tops, get one number, combine the bottoms, get one number. That's not a bad way to go, but I just like practicing my double fractions. So I'm going to say I have negative 8/15. I'm going to put the negative on the top because it's my prerogative. On the bottom, I got 1. Well, down below, I'm just going to call that 1 plus, 32/45. And then, hey, they all go into 45. So I'm just going to multiply everything in the top by 45, everything in the bottom by 45. You don't have to do it this way. You could have just added the fractions. But I think this is going to be faster anyway. So if I multiply the top by 45, 15 goes into 45 3 times. I get negative 24. Plus 3 goes into 45 15 times. So I go 15 times 4, and that's going to give me 60. That's the top of my fraction. Now I can just do that in my head. That's negative 36. And then in the bottom, 45 times 1, that's 45. 45 times the other part, I get a 32, because the cancel. And I can add those in my head. I got 77. So the answer in the book happens to be positive. Where did I mess up? Let me look. Negative 20. Oh, duh. Negative 24 plus 60 is not a negative 36. I am not going to re-record this because I am a goon. That's the answer they have in the book. Ta-da. If you noticed my little boo-boo right there, that's okay. Now, some of you are going, no, I'm not doing that. I wouldn't do the double fraction move. I would combine these. I would combine all this. I would do the top divided by the bottom. You should end up with the same answer then. Just be very careful with your keystrokes on the calculator. Now, here's the thing you're going to notice. Every question, 45, 47, has an answer A, has an answer B, but then they say, in the book, you'll see this. You will see what is the quadrant of S plus T. What is the quadrant of S plus T? It goes back to the axe rule. We're going to take the axe to this thing. We are going to axe this up. So, how do we find out the quadrant of s plus t? Well, when we did the sine of s plus t, my answer was a negative answer. My answer was a negative answer. When I did the tangent of s plus t, my answer was a positive answer. What quadrant would have sine be negative and tangent be positive? Holy cow, let's get another color just for kicks here. USA, red, white, and blue. Come on. Remember the axe rule, or as Quigley says, all students take calculus. This is the way our book says it, axe. Well, in quadrant 1, everybody's positive. But there's only one place where tangent is positive while sine is negative, and that is quadrant 3. So find the quadrant of s plus t. That's how you do it. So take a look at the answers again. And look, I only gave you 2 questions because they're time-consuming to get where you need to get. But just remember, what are we really doing a lot of in section 5.4? We're practicing the sin cos cosin and the tanna tanba. But that's how they got their quadrants. When you look at the answer here, you already have it. If you're checking your work, you should have gotten part A to be a positive answer, part B to be a positive answer. Sine and tangent are both positive in quadrant 1. And then for problem 47, look, that answer's positive, that one's negative. Where is sine positive and tangent not positive? That's in quadrant 2. So that's how they got that answer. I kind of give you the answer to that, but you'll probably forget while you're working. And when you work, come back and check and go, okay, I got it right. All right, we only have one more lesson to go for section 5.4. It has to do with identities, but what you are going to find is the identities are not that bad. Let me give you a couple examples in the next lesson, and I'm sure you'll agree. Okay, signing off.